look at the correlations guide here. And the first key point is that there are two different types of correlation that we use. We use Pearson's R, or we use Spearman's Rho. And really that's going to depend on what you find when you're working with your assumptions and what we tell you to indicate based on your assumptions. So the first thing is that when we're talking about a correlation, the research question is always related to a relationship. So in this case, is there a statistical significant relationship between study time and exam performance among undergrad students? Now, that could be a relationship between multiple variables here and one research question, or it could just be the two variables. If you have multiple, you just do the correlation multiple times. So then we have the null hypothesis, which is there is no statistically significant relationship between your variables, or the alternate, which is that there is. So that's how you're going to structure your initial part of this. And so then we launch into our assumptions. So again, you can only check two variables at a time. So if I'm trying to look at how study time is related to exam performance, I have to look at those two first, but then I could also be interested in how GPA leads to exam performance. If that's the case, I have to do multiple correlations. You don't have to give all of the prereqs multiple times necessarily, because something like a continuous variable, all that really means is that a number could take on any value and that it is going to be continuous. So the number of hours you study, it can take on any value. It's not like you're in category 1, 2, 3, 4, but also exam performance is also continuous because again, it could take on any value in that range. So that's a pretty simple assumption. It's going to be true 95% of the time. The only time we really see that it's not true is if you are looking at something like a Likert scale. Now, if you're doing a survey and you get a subscore, that's very different than a question that asks you to rate something. So that's why when we use surveys, we don't use the questions themselves, but we'll use the subscore that you get for something because that is continuous. Then assumption 2 is that there's linearity. The two things are linearly related. If they're not linearly related, we can still do things with it. But if they are, then that's important to know too. So you'll see the appendix has these instructions, but basically in SPSS, you're going to go to Graphs, Chart Builder. You're going to go down to the scatter plot, and you're going to drag it in. Once you have your scatter plot, you're going to look at the two items that are related, and you're going to move them to the X and the Y axis, and you're going to click OK. So now I have my output, and I mean, it's kind of clustering in the middle of the graph. It doesn't have a great linear relationship, but you're not going to see a completely straight line. So when you're looking at this, notice how you still kind of have some clusters. The big thing is that it's not curved. So if I look at this output, I can draw a line through it and there's no clear curved pattern. So I'm good to kind of keep going at this point with my relationship. If you go up from the left to the right, that's going to be positive like this. If you're going down, then it's going to be negative. So if I look at this graph, it is definitely going up because I would have to draw my line up. So in this case, it's a positive relationship, which means as exam time increases, so does the time spent studying increases, so does the exam performance. If it went down, this is what you would say. And if the steepness is pretty low, like if it's a horizontal line, we would probably say that something's not really changing a whole lot. So right now, it's pretty rare that we don't see a linear piece. If we do see a nonlinear, again, here it's where it happens. We just choose Spearman's. So if you were seeing this kind of curvature, you would just, instead of the table and looking at the Pearson value, you would just look at the Spearman value. And so here, you're going to put the graph of your scatter plot in, and then you're going to adjust your template for the write-up. Again, if it's not linear, then you would follow these steps. If it is linear, you're going to continue on with Pearson's. So if you see that it's nonlinear, essentially all this is explaining is that when you get to your information table, you're going to look at the column that says Spearman's. You don't have to action all of this really technical stuff. You just need to know that you need to look at Spearman's. Then we're going to test for outliers with our typical method of using the Shapiro-Wilk test. So this is the same as a t-test, as a regression, as everything else. You're going to go into that appendix, and in that appendix, you're going to run the Descriptive Statistics Explorer. You're going to move your variables in, and you're going to check off your items. So if I go in here, I'm going to go into my Explore menu. I'm going to move the variables that I'm working with into the key places. I'm going to make sure I check normality, factor levels together, and I'm going to get both my Shapiro-Wilk and I'm going to get all of these table values, but all I'm really looking for is the Shapiro-Wilk and the box plot. So you're seeing way more output than you ever would need to know. And again, this is just because in what we see here with data analysis software is that it's different. So here I see I have a 22 and a 20, which are going to be outside of those little box plots. So I do have 2 outliers here. So I am going to have to decide what to do with my 2 outliers. And then you have your Shapiro-Wilk table that's going to populate as well. So they are telling me that things are dependent. Let me just go check my analysis. I went to descriptives, explore. Oh, I put 1 in factor, that's why. So I just want to look at math achievement. So now I have math achievement. Here's my box plot. There's no outliers for math achievement. Here's my Shapiro-Wilk for math achievement. Then I'm going to have to test it separately because I don't want to put it in as a factor for that mosaic. So in every correlation, you have 2 variables. You're going to have to run this 1 variable at a time. Now, if you look at what's happening with mosaic, I have a lot of outliers to address here. And I also have my own Shapiro-Wilk. So again, correlation has 2 variables. You're going to run 2 Shapiro-Wilk tests so that you can get your outliers answered and you can have 2 Shapiro-Wilk tables. So what that means for this packet, as you're looking at that correlation, you're going to need to insert 2 box plots here, and then later you're going to insert both Shapiro-Wilk tables, and you're going to have this appear twice. So you're going to have to say for the first variable, the box and whisker plot didn't have any outliers from what I saw. So I'm going to write this up, and then I'm going to say the second box plot with the second variable had outliers. And this is what I decided to do. Same thing. You're going to have 2 Shapiro-Wilk tables for a correlation because there are 2 variables. So at this point, you've run all of your assumptions. You've looked for outliers. You've decided if you need Pearson's or Spearman's. And then you're just going to run the correlation. So you're going to go into Analyze, Correlate Bivariate. You're going to move the 2 variables into the box that you want to study. So for me, it's these 2. You're going to check Pearson and Spearman so you can show both. So again, remember, normality tells you what to use for Spearman, or you have Pearson based on that linearity graph. Here's my correlation information. So the correlation for this is 0.213 is my Pearson correlation. my Spearman's correlation is going to be 0.263. So again, this goes back to if your scatter plot was curved in this step, then you're going to use the Spearman output down here. If it was linear, you're going to use the Pearson output, which is here. Then you're going to look at what do I say about those values based on this SPSS output. So if I'm looking at Pearson and I have 0.338, then that's telling me I have some information that I'm going to report out here like this. So I'm going to say the Pearson correlation is represented as follows. R, and that's because it's Pearson. Pearson is an R, of 73, which the 73 is coming from the N of 75 minus 2, equals, and I actually don't like to round, so I don't like to do 0.34. I would typically say 0.338. Where the p-value, which is what's down here, is 0.03. Which means if it's 0.003, I'm going to reject the null hypothesis, which means that there is a statistically significant relationship between math achievement test and mother's education in this instance. Or if I'm looking at my table and I'm looking at Pearson's because I didn't see that curvature, I have 0.213 as my Pearson correlation number, but my p-value is 0.067, which is greater than 0.05, and because it's greater than 0.05, I'm going to fail to reject my null hypothesis, which means my null hypothesis, again, going back to this packet, is that there is no statistically significant relationship between my variables. So here that means that there's no statistically significant relationship between math achievement and the Mosaic test. I'm going to go in my packet, I'm going to insert that table, and then I'm going to do the write-up that's down here. And that's how you look at a correlation. A lot of times we're looking at more than just two things that are related. So you would simply repeat this every time until you have found the relationship with every piece and every item.